Question 13, and Naomi's doing a survey, and what she's done is she's gone for opportunity sampling. So basically, she's just gone for the simplest one she can. So she's just found the first 25 people she sees. Very lazy, very prone to bias, and really not a good idea of taking a sample like that. The data she collected is the number of hours. So the number of hours is a continuous measure. And you can do 1 hour, 2 hours, 1.2 hours or something like that. The fact that she's then rounded it to the nearest whole number doesn't actually change the type of data it is. The data is continuous. She happens to have collected it to the nearest hour. Linear interpolation to find the interquartile range. So we need to find out where a quarter of the data is and then where 3/4 of the data is. Well, a quarter of 25 is 6 1/4, 6.25. So we need to go up to the 6.25th one. Well, clearly we've had 4 up to there. So we need to go another 2.25, sorry, another 2 1/4 into this group here. So we're going 2.25 out of that 7 times by the width. Now the width of this one, notice this is going from 12.5 to 16.5, so the width of this one's 4. And we're going that far into this group here, so clearly it's got to be bigger than 12.5. So this is the calculation we're doing here. That works out to be 13.7857. And we'll do the same for the upper quartile. So 3/4 of 25 is 18 3/4. We need to go up to the 18 3/4 one. Well, look, up to here we've had 11, so we need to go a bit further into this group. So I said we'd had 11, didn't we? So we need to go another 7 3/4 here. So we've got 7.75, 7 3/4, out of this whole group is 12. Times by, and this was the width. Well, the width of this one is from 16.5 to 25.5. So the whole width of that one is 9. Add on to the lower end of it, which is 16.5. And so the upper quartile is turning out to be 22.3125. That means that your interquartile range is 22, take away 13, which gives me 8.53.